Okay, 7.4, we're going to learn about the sum and difference formulas. So that's all we're going to do, and we'll use them to evaluate trig functions, verify identities, and solve some equations. So here they are. They're all on our formula sheet right here. Actually, I put these 4 on our formula sheet, and these ones right here just come from sine over cosine. So like if you look at this formula right here and do divided by this formula, you'll get this. So if we do tangent at all, just keep in mind that it's sine over cosine, so you can use the 4 that I give you on the formula sheet. All right, so let's use those to find the exact value of the sine of pi over 12. Now, what we're going to do is we're going to turn the pi over 12 into either the sum or the difference of 2 angles that we have on our unit circle for exact values. So, and I don't know what those angles are, so what I do is I convert this to degrees first. To convert it to degrees, we're going to do 180 over pi. Pi's cancel, and we get 15 degrees. So I'm going to make, instead of having the sine of 15 degrees, I'm going to do 45 minus 30. All right? So I'm going to change this into the sine of 45, which is pi over 4, minus 30, which is pi over 6. Turns out, now if you do this, if you actually combine those fractions with the common denominator, you will get pi over 12. So you can always double check. But this is what I'm going to do right here. Now, above this, I'm going to write the sine of angle U minus angle V, because we have a formula for that. So you can just write that down right off the formula sheet. Make sure, since you're in the bottom here, on the formula sheet, you stay in the bottom with as far as the sign goes. So be careful about the sign. And now we just need to rewrite this. So the sine of angle U, this is angle U, and this is angle V then, obviously. So it's sine of pi over 4, cosine of pi over 6, minus cosine of pi over 4, sine of pi over 6. All right, now we can simplify this because using our unit circle now, the sine of pi over 4 is square root of 2 over 2. The cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. And the sine of 30 degrees is 1/2. So we can simplify it to this and then simplify it further. This becomes, actually, I'll leave it as the square root of 2 times the square root of 3 for now, all over 4 minus the square root of 2 over 4. I'll simplify it a little bit further, so I'll pull out a square root of 2, leaving me with the square root of 3 minus 1 in the top, and in the bottom I'll just make it 4. Obviously it's a common denominator. So we can rewrite it different ways, but that'll work just fine. There's our exact value for the sine of pi over 12. Okay, we can do other things as well. We can prove identities now using our sum and difference formula. So what I'm going to do is write down the cosine. I'm going to start with the left side, the more complicated side. I'm going to work to get the right side. So I'll write the cosine of 90 minus x. Now I'm going to write above that the formula for the cosine of u minus v, right off the formula sheet. So that's the cosine of u, cosine of v, plus the sine of u, sine of v. Stick with the sign in the bottom of the formula. So let me just show you that real quick. Right here, the cosine of sum or difference, we're using the sign in the bottom, cosine of u minus v, so we got to use the sign in the bottom here, so stay with the bottom. So it's going to be a plus right here in the formula. That's important. Okay, so when we fill this out then, angle u is pi over 2. This is cosine of x now, plus sine of u is pi over 2, sine of x. Now, the cosine of 90 degrees is 0. So this whole first term drops off. And the sine of 90 degrees is 1. So this whole thing becomes the sine of x. And this work right here is all I need to show it right here. So I've just verified this identity. Now obviously you can have this written there. That's just to help. That was to help me with the formula, which you're more than welcome to write down. But this is, you know, the work right here shows that this left side equals the right side. All right, let's try a really tough one, solving a trig equation using this. So I'm going to rewrite the sine of x plus pi over 4 using the formulas. I'm not going to write the formula above it now. I'm just going to look at the formula sheet and fill this in. So hopefully you can get good at doing this as well. This becomes the sine of the first angle x times the cosine of the second angle pi over 4. And it's a plus, so it stays in the top. So it's plus cosine of x sine of pi over 4. Now I'm going to try to simplify that if I can. Actually, before I simplify, let me do the other one. Let me do this term now here, which is x minus pi over 4. I'm using the same formula. The only thing that's different is the sign's going to be different. So it's going to be sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. Now when I add these together, because that's what it's asking me to do here, so add these together, and when you do that, these cancel. So you're just going to get 2 sine of x cosine of pi over 4, and we want to know where that's equal to negative 1 in the interval from 0 to 2 pi. So now we're solving this. All right, now I'm going to simplify this. So this on your formula sheet, or on your unit circle rather, is square root of 2 over 2. So the 2's will cancel here and I multiply. So I'm left with the sine of x times the square root of 2 equals negative 1. Let me divide both sides by the square root of 2 now. Okay, so now I have this. Let me simplify this negative 1 over square root of 2 by rationalizing the denominator. If I multiply top and bottom by the square root of 2, I rationalize the denominator, which is negative square root of 2 over 2 now. So what I'm looking for is, where does the sine of x equal negative square root of 2 over 2 on your unit circle? So if you look at that, that's the y value. That happens here and here at 5 pi over 4 and 7 pi over 4. And those are my solutions for x. I don't have to add intervals of 2 pi here because it just wants the solutions in the interval from 0 to 2 pi. So I only want this solution here and this angle here. All right, so there's my answer. All right, let's try the homework and hopefully this will help.